Hello and welcome to the Chemistry Academy. In this video we're going to go over the regions of the electromagnetic spectrum in relation to the Advanced Higher Chemistry course. This video shouldn't be that long because there's not really all that much you necessarily need to know about the regions of the electromagnetic spectrum. There's just a couple of key points that you need to be aware of, and then you can apply those key points to any of the questions you are presented with in relation to the regions. So if we just get started, the first thing that's very important and vital that you know is the order of the regions of the electromagnetic spectrum. So the electromagnetic spectrum is just all of the wavelengths, frequencies of light that we receive from the universe. So light travels in photons, defined quantities of light, and those photons will have specific energies associated with them, specific wavelengths and specific frequencies. So the electromagnetic spectrum essentially breaks these wavelengths and frequencies up into smaller sections that is then more relevant to how much energy they carry and also what they can potentially then be used for application-wise. So the regions that we have are radio waves, microwaves, infrared region, visible region, ultraviolet, X-ray and gamma. So these are all different regions of the electromagnetic spectrum. In terms of remembering the order of them, you can come up with your own mnemonic if you like, or you can use the one I've got here. My favourite one is red Martians invade Venus using X-ray guns. So that scenario, that wee mnemonic, then gives you the first letter of each of the regions in order, so that it can then help you in your exam, under exam pressure, remembering which order those regions go in. I did ask ChatGPT to create an image to illustrate this, so I'll add this onto the video. Just if you're more of a visual learner, it can help you remember. So yeah, red Martians invade Venus using X-ray guns, but if you do have another one that you come up with, so let me know in the comments what it was, because I'm always interested in new tips and tricks on how to remember things. Once you've got the order of this electromagnetic spectrum regions nailed, then you need to also know then which regions have the higher wavelengths and the lower frequencies and the higher energies and vice versa. So I've got this listed here. As you go down from radio waves to gamma waves, you end up with a decreasing wavelength, so the waves get shorter. When the wavelength is shorter, it means the frequency is higher. So wavelength is essentially, you remember from your National 5 maths days, essentially how long it takes for one wave to occur. So whatever that distance is, that is the wavelength. The frequency is how many waves you get in a certain period of time or across a certain distance. So if the wavelength is shorter, what tends to happen is you end up with a higher frequency. So say these are the same distances here and here. So this frequency, the number of waves that are occurring in a certain reciprocal, is greater, so that's a greater frequency. So yeah, because when the wavelength's long, you tend to have a lower frequency. There's less waves can fit into that given period. That's how to remember that they're opposite to each other. Okay, so if wavelength is high, frequency will be low and vice versa. And then when it comes to energy, lower wavelengths have higher energies associated with photons of those wavelengths, and then therefore a greater wavelength would have lower energy associated with it. Now, this is maybe the bit that people struggle the most to try and remember which is which. So there are actually a couple of equations in the front of your data booklet that you can use to help you remember these things. So it's these two equations here. This one's got energy and wavelength in it, and this one here has got energy and frequency in it. So this helps you remember or work out the relationship between energy and wavelength and frequency. So if we look at the first one, and this is something that used to get taught in like standard grade maths, but they don't teach it in maths anymore, I don't think, which is a bit of a shame. But essentially what we would call the relationship here between energy and wavelength is that they are indirectly proportional. So to me, I always remember that just means that one's on the bottom of the equation, or like the lower ground of the car park, and the other one's on the top. So they're on different levels. So that means if one of them's high, the other one's low, and vice versa. If this one is high, then this ends up being low. Okay, so an indirect proportional relationship means they're like opposites to each other. in terms of how they relate. And then this one here, the E and the F, energy and frequency, are on the same level of the car park, which means that if one of them's high, the other one will also be high, and vice versa. If one of them's low, the other one will also be low. So you can use these equations to remember the relationship. So really, all you need to remember is one of these three patterns, because then all of the other ones you can work out. So I usually always remember the wavelength ones. I don't know why, I just find it easier to remember that the radial waves are really long ones, and that gamma rays are really short ones. But whichever one works for you, and then, like I said, you can always use the equations to work it out. So if we know that the wavelength is decreasing, we know that wavelength and frequency are opposites. So if one's high, the other one's low, and vice versa. And then we can see from the equations that if the wavelength is low, then the energy has to be high. Okay, so that would be my advice for remembering those. And then again, you'll just get asked questions on like what order certain regions should go in, which ones have a longer wavelength, which ones have a shorter wavelength. In this section 2, there's a lot on the colour of transition metals, stuff that you'll do eventually, and colour of organic compounds that's to do with energy gaps and the wavelengths of those energy gaps then resulting in the colour that's seen and things like that. So it all does tie into some of the other stuff as well, which is why it's really important that you know that when wavelength is short, energy is high, and vice versa. There are also some questions on the electromagnetic spectrum that the colour wheel can help you with. So the colour wheel is on page 19 of your data booklet, and it'll essentially show you the visible region of the spectrum. It'll then also, around the outside, it has the wavelengths of those regions. Sometimes you will get a question in the multiple choice that asks you what region of spectra a certain wavelength falls within, and the wavelength is maybe not in the visible region. So you're thinking, I don't know, and that doesn't mean that you have to memorise all the wavelengths of all the different regions, because in my experience, generally, if it's a wavelength that's less than 380 nanometers, so that's like on the shorter side of the visible region, then that will mean it's most likely a wavelength that's in the UV region. Okay, it doesn't tend to be one that's even shorter and further along towards X-ray or gamma. They won't tend to ask you about them. And then if you end up with a wavelength that's above 700 nanometers, so longer than the visible region, then it's most likely going to be a wavelength within the IR region. It's very unlikely to be microwaves or radio waves. And that's just based on my experience of what the exam questions have kind of been like over the years. If you're wondering how am I going to remember which one's on which side, the colours in the visible spectrum actually help you. So you may notice that at 380 nanometers you've got purple or violet. That's then, beyond that is where you would get ultraviolet region. At 750 nanometers, or shorter than that, you've got the red region of the visible spectrum. That's then, after that, you get the infrared region. So the colours of the visible region can help you remember which one, the UV or the IR, comes either side. Okay, so next to the purple, violet, you've got the UV. Next to red, you've got the IR. And that is really it. So it doesn't really seem like that much, but you will see if you go and try some past paper questions on this, or any of the quizzes in my Advanced Higher Google Classroom, if you're in that, what sorts of questions they'll actually ask that require you to apply these things. So yeah, hopefully you found that helpful. If you did, please give this video a like. Don't forget to subscribe, and yeah, if you're looking for more support on your Advanced Higher Chemistry journey, don't forget you can join my Advanced Higher Chemistry Classroom. If you go to my website, www.thechemistryacademy.com, you will be able to find how to access it there. Thank you, and see you again soon.